Welcome to the Grade 3 Video TLC with Content Coordinator. Today's TLC will be discovering the misconceptions of the. So our plan of attack is that we will begin by reviewing the lowest performing TEKs from your Unit 11 check, and then we'll share some strategies and lesson suggestions for your spiral review or Longhorn time. The TEK that students struggled with the most was 3.7B, with 51% of our students being successful. So we had a little over half. This particular TEK covered was part of the strand of geometry and measurement, where they apply their mathematical process standards to select their appropriate units, strategies, and other tools to solve problems that will involve metric measurements. This particular TEK, students were to determine the perimeter of a polygon or find the missing length when given the perimeter and the remaining side lengths in the problem. So we're going to break this down and look at what do students need to know and what do students need to show in order to demonstrate understanding. What students really need to understand are the attributes of polygons. These polygons could be equal in length on all sides or have equal and opposite lengths, or all lengths are at different sizes. But they do need to understand those attributes. Once students understand that, one of the things that showed up on STAR was that they were given a rectangle and they had to be able to figure out the missing length of one side when only given the length of one of the sides. So for example, they will determine the missing length of a rectangle by calculating the differences between the perimeter and the sum. Once they find out that difference, they will take that difference divided by 2 to give them the length of that one side. And I'll go more in depth on what that looks like because that was a big one and that's where our students struggled the most. Also, understanding the difference between determining the missing length of shapes that have equal side lengths and also when they have unequal side lengths. So there's a lot to unpack as far as what students need to understand, but those are the things that you want to focus on instructionally with your students when you are reteaching. Students will demonstrate the understanding by being able to determine the unknown side length of any polygon, especially when the polygon has unequal sides when they are given the perimeter and some of the side lengths. Determine the unknown side length of a shape with all equal sides, especially once they're given the perimeter, they could figure that out. And then to determine the perimeter of a polygon when given the side lengths. So there's several things that we want to make sure that they can do when to demonstrate successful understanding of this particular TEK. So let's look at that problem I talked about in STAR. On STAR, they were given this problem where Vince built a fence around his rectangular garden. The perimeter of the garden is 26 feet. The length of the garden is 8 feet. What is the width of the garden in feet? On STAR, like we said, students needed to understand what are the attributes of a rectangle. We know that the rectangle has equal and opposite sides. They also were given the perimeter and they were given the length of one side. So when we go back to our no, that focuses with these two skills. Do they understand what makes a rectangle and the attributes of it? And do they understand how to find the missing length when given the side and the perimeter? And that's what happened here. So we're going to go over how we can use a different strategy to help our students solve this. So let's talk about those strategies. Your strategies for reteaching, we always look at it in two folds. You're going to look at context or you're going to look at computation. Context is the most important part of 3.7B, and computation is the part that will help them get the answer. But if students do not understand perimeter and how to unpack a problem situation to figure out how to find the perimeter, then having the correct computation skills will be null and void. They have to understand the problem before they can do the correct computations. So let's take a look at our problem that students had on their unit check. In this problem, students were given the perimeter and they were given side lengths, but they were missing one that they had to find that missing length. So we're going to talk about a strategy that students can use, and that is using strip diagrams. The reason why I want to use the strip diagrams with students, it is a great bridge for students as they move to formulas and just being able to plug in the formula. A lot of times we teach students a formula and that really just goes into the how and it doesn't really address the why. Strip diagrams are a great way to address that why, which really helps with that contextual understanding that we want our students to have. For example, with the strip diagram, as we break the problem down, we want to talk about the first part. The top part of the strip diagram, students are very familiar, is the total. Well, if you make that connection with perimeter, perimeter is the total distance around the shape. So at the top of our strip diagram, we're going to put 30 units because 30 units is the total distance around. The next thing we always look at are the attributes. What are the sides and what are those lengths of those sides? Are the side lengths the same? Are the side lengths different? If we look, we know that this shape has 4 sides. So on our strip diagram, we're going to have 4 sides. And we're also going to look at the lengths of those sides. Well, side 1 is unknown. So I don't know the size or the length of side 1, so I'm going to put a question mark. Side 2, we know the length is 7 units. Side 3, 12 units. And side 4 is 7 units. If there were 3, they would only have 3 boxes because it's a triangle, it only has 3 sides. If it's an octagon, you would have 8 boxes for 8 sides. So the number of boxes determines the number of groups. So that's that connection with multiplication and division when it comes to, or addition and subtraction when it comes to our strip diagrams. So once the students have unpacked the problem and they developed their strip diagram, now we can have the conversations about what will we need to do in order to find that missing length. A lot of students already know, well, if I'm looking at this, I'm going to add 7 plus 12 plus 7, and then I can take that away from 30 to find the missing length because they've had experience with that. They understand that. So now we're just making that connection to the perimeter and finding the missing length. So then helping students take that and write an equation would look something like this. To the next level, what do we also notice? Can we use multiplication and addition when it comes to this? Yes, we can, because we can say there are 2 groups of 7. 2 sides have 7. So when I do multiplication, I never say times with students. We always say groups of. So there are 2 groups of 7 plus my 12 plus the unknown. All of these together will give me my 30. So then we could talk about, so how can we solve for that unknown and having those so that way students have a plan and then we work on computation. But it's so important to help them have those conversations and to plan and develop their understanding of what's happening using the strip diagrams. So let's look at what that looks like instructionally when you are having those small groups. Before we do that, this strategy, I just want to read, this strategy only works if students have a deep understanding of strip diagrams. If they don't have a deep understanding of strip diagrams, this strategy is just going to be more confusing for them. This only works if students understand it because that serves as that bridge. If they don't have that understanding, the bridge is not stable, they're not going to be able to do it. So let's talk about how this looks. We're going to make connections with strip diagrams when we're talking about perimeter. So let's look at our first problem. In this problem, each side of the figure is the same length. The perimeter of the figure is 72 inches. What is the length of one side of the figure in inches? Typically, we tend to teach our kids, well, it says each side, and the whole thing is 72. So we're going to look at our form, and we teach them a formula. But in this case, we're going to go back to the understanding strip diagrams and use that as our anchor. When you are planning your instruction for small group during Longhorn time, please develop your scaffolding questions. What you want to do is solve the problem using the strip diagram first, and then develop your scaffolding questions after you have done it, because now you kind of know the process and then you can come up with the questions to help students through the process. The first couple of times you do this, ask the questions, but you're going to find that students may not be able to provide the answer. That's fine. If they cannot provide the answer, that becomes your time where you are going to directly teach that part that covers that question asked, not the whole thing. You want to go through the questions and give students an opportunity to answer to see if they know, and if they don't, then you're going to go back and reteach that part. So for example, if this is me doing this with my students, number 1, what do we know about perimeters? Most students can tell me perimeters is the distance around. Great. So if we know perimeters is the distance around, how can we show the total distance around the octagon using a strip diagram? Hopefully, students will then tell me that they'll put a strip diagram, a bar, and they'll put 72 at top. If they cannot, that's fine. Okay, great. I'm going to show you how I would represent the total distance of 72 inches of the octagon with my strip diagram. I'm going to draw a bar. This bar represents my octagon. At the top of the bar, I'm going to put 72 inches because 72 is the total length. I want you to do that on your paper. Okay, so students would go through that with me. And then I'm going to ask my next question. So what do you notice about the side lengths of the octagon? Some students will automatically tell me there's 8. But that's not where I want them to go. So you may rephrase the question. Great, there are 8, but what do you notice about the lengths of the octagon? What do you notice about the lengths for each side? Hopefully students will say that they are equal. You're right, there are equal, all the sides are equal. How many equal sides are there? Students will be able to tell me. I already know. That's an easy answer for them to give me. Now that we know that there are 8 equal sides on this octagon, how can we add this information to our model? If students are unable, then that's when you will step in and you will model that you put 8 sides at the bottom and you draw 8 boxes. Each box represents my sides. Do I know how long each side is? No. So I'm going to put a question mark because I don't know the size of the size of the sides, but I do know the number of sides. Once I have this, then based on our model, what can we do to determine the length of one side of this figure? Hopefully students, because they've had experience with strip diagrams, they're looking at it. Students will tell you, I'm going to divide 72. Now I'm going to divide 72 by 8. Or some students will give you the multiplication. Well, I'm just going to use multiplication. 8 times something gives me 72. Either way, students will get the answer of 9, which is correct. So both solution paths work. So let's look at another one. Once they have experience, go on ahead and create that anchor chart as you see up here. The top is your total distance. The boxes represent the number of sides, and the number that goes inside is the length of the sides. So when students have that, they're making that connection, then we can look at another problem. A triangular sign has a perimeter of 44 centimeters. 2 of the sides are 14 centimeters long. What is the length of the third side in centimeters? So I want you to think about what questions you can ask to help students represent the problem using a strip diagram. That's just something you would want to think about. So let's look at another one. So here's one here where, again, here is my anchor chart up top. This problem says the side lengths of a rectangular mirror are shown in inches. What is the perimeter of the mirror in inches? So now you're going to have once you've worked it out, have your scaffolding questions to help students get to this. What do we know about perimeters? Students will tell the perimeter is the total distance around. Well, we know that the perimeter is the total distance around the shape, but in this situation, we don't know that distance. How can I show this unknown in a strip model? Students should be able to tell you. They'll put a question mark at the top. If not, you will model that for them. What do you notice about the side lengths of the rectangle? Because this is a rectangle and we know that rectangles are equal and opposite, if 18 is at the top, then I have to have 18 at the bottom. If 28 is on this side, because it's equal and opposite, the opposite side will also be equal. Good. How can you add this information to your model? So we're going to do 18, 18, 28, 28. Based on your model, what can we do to determine the perimeter of the mirror? Well, we're just going to add all 4 sides to get that. Great. Now, if they only show you addition, you can model what does that look like with multiplication and addition. Well, multiplication, I have 2 groups of 18, so I do 18 times 2, or 2 groups of 18, and then I have 2 groups of 28. Here's that problem that we talked about that showed up on STAR. This was going to really require you to do a lot of the modeling, but still have those scaffold questions ready. Scaffolding is so important because it does direct the thinking that you want students to think about, and you're going to ask them out loud. Still give students the opportunity to tell what they're thinking. And then if the thinking is off or there's misconceptions, then that's when you will correct those misconceptions and model that part. So Vince built a fence around his rectangular garden. The perimeter of the garden is 26 feet. The length of the garden is 8 feet. What is the width of the garden in feet? First question, what do we know about perimeters? Same question, perimeter is the total distance around. How can we show the total distance around the rectangular garden using a strip diagram? I'm going to put my 26 at the top because that is the total. What do we know about the side lengths and widths of rectangles? They are equal and opposite. Well, they did tell us that one side is 8 feet. So I know I'm going to put length and I'm going to put width because those are my sides. There are 4 sides to a rectangle. I know if one side is 8, the other side has to be 8. But I do not know the width, so I'm going to leave those blank. So far, we know one side of the length is 8. So we also know the opposite sides are equal. So based on our model, what can we do to find the total width? Because we want to know that width, right? Well, we're going to add these two, and then we can subtract them, and what's ever left will be the width. So our formula is 26 equals 8 plus 8 gives us the width, or 26 equals 2 times 8 will also help us find that width. That is the first part. Remember, this is a 2-step, and that's what you can explain. So now we know that 10 is the total of the width. So I'm going to create a separate model. I'm going to put 10 as my total width, or you can put it directly underneath here. 10, but remember there are 2 sides. I want to know the width of one side. So if I have a total of 10 for my width and both sides are equal, what can I do to figure out the width of one side? And have students tell you, well, that's 10 divided by 2 will give me 5, or 2 times something will give me 10. So there are 2 different formulas or equations that students can have. And doing this over and over again will really help with that thinking. You can do it with triangles, you can do it with whatever you want, but you just want to make sure that students can, actually this one only works with rectangles because it's a special problem, but this one is more likely to show up on STAR for 2024 because it was such a issue with 2023. So I would really spend time making sure that students can think through these problems. So your lesson suggestions for daily routines. For your daily routine, I am going to recommend that you use the STAR Countdown Gauntlet. Pre-select your questions from the page to be completed first, including the focus TEK of 3.7b. So here are all of the, I've gone through the gauntlet. I've only went through half. There are more series than the ones I'm showing, but out of the first 10 series, these page numbers do have the TEK 3.7b. So how this would look in your classroom is make sure before you meet with students, you want to assign the problems in advance. Just by looking at this, I know I'm going to give my students 5 to 8 minutes. There are only 4 problems. I think they can do all 4. So I'm not going to do a must do, may do. They're just going to do all of them. And essentially, if there are more than that, some series will have up to 8 questions. You will probably have to have a must do and a may do and a can do at that point. It just depends. Set your timer for 5 to 8 minutes, and students will work on those assigned problems. If they finish early, then they work on the other problems that you assign. But make sure that you give enough time for that to be done. Do not use the whole 15 minutes for them to work on the whole thing. You need time to do your quick reteach lesson that you're going to do. So you're going to cut that time in half and think about what can they accomplish within that half. And for our fast finishers, they can do the rest. But you only want to give a small amount of time. Review the answers for everything that they've done, but then use the remainder of the time to go more in depth of 3.7b. You can have another example ready for them to practice the same type of problem, but do it a different way. But just be ready for your reteach. How does that reteach look using that problem from 3.7b? That's what you want to plan for your daily routines. Another hint, write out those multiple choice questions and have students record the answer instead. So when I look at this problem here, I would leave number one the same. I would leave number two the same, but I would white out the answer choices for number three and number four. They can just write it in. That way I can have two problems where they can write it in instead of everything being multiple choice. Your lesson suggestions for your Longhorn time. The Ultimate Math Grade 3 practice set, pages 79 through 84, are directly related to just 3.7b. Also, your Countdown to Star Fast Focus, 3.7b, or you can go into Serious and your Readiness Instruction Practice, Problem Solving 11.1 and 11.2. And the great thing with Serious is the problems are a little bit more advanced. In this problem, you notice that you have three different polygons, but they still have to find the perimeter of the whole thing. What's great with this is that you can have students solve this using only addition, and then you can challenge them, how else can we do this using addition and subtraction? I mean, addition and multiplication, because if I have 5 over here and 5 over here, 5 here and 5 here, well, I could do 5 times 4 because there are 4 groups of 5 plus 12 times 2 plus my 9. So that is how I could do multiplication and addition in this. And that's just pushing their thinking to make sure that they understand where perimeter is, because that still gives me the distance around all the way. So this is just a review of your lesson suggestions. When I do send the email to you, then you will have this as well. Here are all the series that do include 3.7b, and here's everything you can use for Longhorn time. If you have any questions, please send your questions via email to me, and I'll respond to them as soon as possible. Thank you for watching our video, and I hope to see you next time. Thank you.